So when you're presented with a keypad for the first time and you don't have a really good intuitive sense for how it works, don't start programming with it right away. Don't connect it up to your Phidgets board. The first thing that you want to do is to test the electrical connections on the individual pins to make sure it works properly. What we've done right here on the Excel spreadsheet is to give you a mapping between the actual keys on the keypad and the pins and posts representing the rows and columns for the matrix of the keys that are on here. So you'll notice that the columns are defined by posts or pins 5, 6, and 7. 5, 6, and 7, 5, 6, and 7, 5, 6, and 7 over and over again. And the rows are defined by pins or posts 1, 2, 3, and 4. So what we're going to do is use the multimeter right here. We're going to set it to the sound symbol right there. And so it looks sort of like a Wi-Fi symbol that you see on your cell phone or on your laptop. I'm going to switch the mode so that it says sound detection or sound connectivity, basically. I'm going to put this aside right here. Okay. Now I'm going to use the two probes on my multimeter, and I'm going to connect them up to try and detect key on keypad number 1. And that means I need to connect up posts 5 and 1 together using these two probes. So I'm going to connect this one up to post 1 like this, and this one I'm going to put into number 5. Now I'm going to press random buttons and nothing goes off. I'm going to press 1, and wouldn't you know it, it goes off. All right, so now I'm going to keep the black lead in post number 1, and I'm going to switch the red one over to post number 6. So I'm going to press the number 1 again, and nothing happens. I press number 2. There we go. I have to press it hard enough. Press it down hard enough, and it goes off. If I switch this out into 7, 1, 2, 1, 2, 3. Button number 3 goes off. So that's all really good. So now I'm going to switch over the black probe from the multimeter into post number 2. And I'm going to take this red one, I'm going to put, I'm going to put it in post number 5. So I'm going to go recover that black lead, put it in post number 2. This is why you need a lab partner. Okay, this is definitely why you need a lab partner. Okay, so I'm now going to press 1, 2, 3, and the button number 4. 4 is being detected. I switch this red lead over to post number 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we see that it's detecting that. Then I put this into post number 7. 1, 2, 3, 4, 5, 6. 6 gets detected. I switch over the black one to post number 3. Put this one back into post number 5. 1, 2, 3, 4, 5, 6, 7, 7. Button number 7. This one goes into post number 6. 1, 2, 3, 4, 5, 6, 7, 8. This one goes into post number 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I switch this into post number 4. This one into post number 5. 1, 2, 3, 4, 5, 6, 7, 8, 9 star. Switch that one into post number 6. That'll be 0. Post number 7. That'll be hashtag. And there you have it. So let's imagine for a moment that you don't have a multimeter to do these tests. The next thing that you can use is the power lines on the Phidgets board. So you plug in your Phidgets board to USB power. So you plug that into a computer or to a 5-volt USB charger or something like that. So you got 5 volts that's coming out, and you connect up an alligator clip or a banana wire to the 5-volt post. And then you're going to pretend that 5 volts is going to be one of your digital output connections. And so that digital output connection should be connected to one of the rows. So we're going to connect this up to row number, to row 1 or post number 1. So row pin or row post 1, we connect up 5 volts. Now the next thing, so that's the red wire. So the next thing we're going to do is connect up a ground line, and that ground line is going to be connected up from the Phidgets board right here to one of the two connections that's over on this side of the keypad board. The two black lines, or the two black posts that are found on the keypad board, aren't actually connected up to the keypad itself. They're connected up to LEDs that are found on the outside edge of the keypad. You're going, and in fact, that black post is connected up to the cathode of one of the LEDs. So I'm going to connect that up. So the cathode of an LED is now connected to the negative or ground line of the Phidgets board. The next thing we need to do is come up with a signal line that goes from one of the posts on the keypad board, and this will represent one of the digital input lines. Okay, so it's the detection signal, and for this for our selection right here, we're going to be looking to detect button press number 1. So according to the Excel spreadsheet, we need to connect this up to column pin number 5. So this is post 5 right here. I'm going to connect the other end right here to the red terminal that is found connecting the resistor and LED on the right hand side of the Phidgets board. The keypad board. Now I'm going to press buttons like this and no light comes on. If I press the 1 button, it does. So I'm actually going to bring this out so you can see it a little bit better. I'm going to press button number 1 and the light goes off. 2, nothing goes off. Now I'm going to switch post number 5 to be post number 6. My apologies, that was the multimeter going off there. That wasn't the actual board doing anything at all. So now I've got the signal line that goes into the resistor right here that touches the LED. This is going to be connected up to post number 6. I press random buttons, nothing happens. I press 2 and that button goes off, and the LED goes off. Okay, so 2 makes it go off. I'm going to connect this up to post number 7, and this should allow button 3 to be detected. There you go. So I'm going to put this back over onto post 5, and I'm going to switch the powered line to post number 2. Okay, and this corresponds to the next row of numbers. So I press 1, 2, 3, 4. Whoops. There we go. Is that connected? Ah, there we go. Okay, so the this connection right here had gotten loose. All right, a little bit of panic right there. Okay, so I'm going to press 4 here, and sure enough, we're good. 4. Okay, so I'm going to switch the white lead to post 6, press 5, 5 gets detected, to post 7, 4, 5, 6, 6 gets detected. I switch the red lead over to post 3, bring the white lead over to post 5, and go 1, 2, 3, 4, 5, 6, 7 should go off. There we go, 7. I keep that on 3. Put this over on 6. 1, 2, 3, 4, 5, 6, 7, 8 goes off. Connect up 7, 7, 8, 9. Bring this over onto 4. This over onto 5. 7, 8, 9 star. Star gets detected. 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0 gets detected. And finally, let's see that hashtag. Hashtag gets detected. And there you have it. How to use the Phidgets power in order to detect where the connections are, where the keypad buttons are, and what combinations of rows and columns allow that to happen. So now we're getting ready to connect the keypad to the Phidgets board. We have one more test that we need to run first, and that test involves measuring the voltages that will be associated with key presses. Now, what's important to know is that the digital input lines, these posts right here on the Phidgets board, each have something called a pull-up resistor on them. And that pull-up resistor is responsible for giving a default 5-volt input into each of the digital inputs. It's a safety feature. So when nothing's connected, those digital inputs read 5 volts or logic value of high or 1. So what you need to do with a keypad is to drive that input down to 0 or to ground. So we're going to hook up ground into the rows of the keypad, and by getting a ground signal to run through the row and then to pick that up in one of the columns of the keypad, then we'll be able to detect key press. So here's how we do it. We're going to take an alligator clip and connect it to the ground line, or the ground post of the Phidgets board. I'm going to take that and connect that to pin 1, the row pin 1 of the keypad post right there. Okay, and we're going to be trying to detect the keypad number press 1. So we need to look at the pin number 1 or post number 1 on the keypad board, and we need to connect that to ground because we're going to try and route a ground signal through the row, and we're going to pick it up using column number 5, because as you can see from the Excel spreadsheet here, column number 5 is the one associated with pin 1. So I'm going to connect that alligator clip, the white one, to column the post number 5, which is associated with the column connected to key press 1, and I'm going to route this into digital input 1. So that's the post right here on the Phidgets board. The next thing I'm going to do is turn on my multimeter to voltage measurement. I'm going to take 2 of my leads from my multimeter like this. I'm going to connect one of them to ground. I'm going to stick it into the ground post like this. If I can get that in there. Well, maybe I'll have to hold on to it. Okay, and then the other one I'm going to stick in there. So I'll hold it with my hand like that. And if you can see on here, the multimeter says 4.95 volts. So it's reading the voltage between ground and the digital input. I'm sorry, I'll repeat that. Between the ground line right here and the digital input line 1, it's reading 5 volts. That's the default value for the digital input. Now I'm going to press, say, button 3, watch the voltage, nothing. I'm going to press button 2, watch the voltage, nothing. I'm going to press button 1, and look at that, it goes down to effectively 0 volts. I'll release it, back up to 5 volts, press 1 again, down to 0. 5, 0, 5, 0. Awesome. Okay, so let's try this with a different button. So let's try, let me see. We're going to go for a column 6. And we're going to go for a row, let's see, let's go for 3. Like that. And that would mean, if we're at 6 and 3, it means we're trying to pick up button press number 8. So I'm going to take ground line here. So I'm going to connect the ground post, and I'm going to imagine we're still looking at it on digital input 1, like this. All right. So this is now reading 4.95 volts, so 5 volts on digital input 1 right there. I'm going to press the number 1, no change, 2, no change, 3, no change, 4, no change, 5, no change, 6, no change, 7, no change, 8. And so now we have 0 volts running into digital input 1 because we pressed 8, which is a combination of row 3 and column 6. I release, and sure enough, back to 5, press, release, press, release. And there you have it. Okay, so the next step in developing the code for your keypad is going to be to start writing code. And so what we've done here is modified the basic hello.m file template, and I've called it basic keypad lab. And in it, there is a timer callback delay of 100 milliseconds. That's important because there's going to be a cycling of the code every 100 milliseconds, and we're going to want to take advantage of that. Inside of the code, let me see if I can find something interesting here. I've set up a global variable. The global variable is set up in the main function, and you'll find it right here. I've called the global variable glb count fidget dig out, and this is going to be used to count which of the digital outputs is driving the signal that we're interested in. So most of the digital outputs will be set to 5 volts. We're going to be wanting to keep track of one cycling through from digital output 1, 2, 3, 4. And that's all we need for the keypad, but I'm going to have a fifth one for an LED as well. And then initially what I do is I set the GLB count to 1 to represent digital output value number 1. From there, I set all of the output states to 5 volts. That's what's right in here. And that's all done within the main function. Down at the bottom, in this function right here, I've got a timer callback function. I've recalled the global variable. I don't redefine it. Well, I'm redefining it in the context of this local function right here. And then what I do is I input, or I change the count value from whatever it was before to a new value that is 1 plus that. And that happens once every time, every 100 milliseconds that the timer callback function is called. So this code for the Phidgets board will call this particular function every 100 milliseconds. There's going to be a fprintf statement that goes off. Then there's a reset on this that occurs. And then what I have is an if-else statement that says that if the count for this global variable is less than or equal to 5, so it hasn't gotten past the maximum number that I want to increment, then set the output state of digital output 1 to 0, that is to ground it. Otherwise, what I want you to do is to set the or to reset the global variable to 1, which means that it'll cycle all the way back to the first digital output. And at that point, I want the voltage value on that output set to logic 1 or 5 volts. What will happen on the board is that you'll end up seeing the LED that this is connected to flash once every few hundred milliseconds. Okay, now what we want to do is also show you how I've hooked this up. So what I have is the Phidgets board right here. I have the keypad over here. I've taken the ground line from the Phidgets board. I've connected it to the cathode end of the LED. And you can see the LED lit up right here. I've connected up to the black post of the LED. And I've taken digital output 1, okay, so the digital output post number 1. I've routed it on this green line right here to the red terminal of the LED. When I run the code, I hit run here. I switch over to my command window. You see that it is started running the basic keypad lab function. I hit enter. And you'll see that the fprintf statements are flashing through. And at the same time, you can see the LED flashing on and off as the timer callback is being called, and we cycle through that if-else statement. Okay, so what we've done here is we've connected up the Phidgets board to the keypad board, and we've got one of the digital output posts connected up to the first post on the keypad board. So this first of the digital output posts represents digital output 1. The 0 here is kind of confusing, but 0 represents the first digital output, and I'm connecting that up to the first terminal on the keypad board. And that first terminal on the keypad board represents the pins for keypad characters 1, 2, and 3. So this first row right here. The next thing I'm going to do is, actually before I get any further than that, the other thing to point out is that I've connected up the LED over here to the, let's see, digital output 1, 2, 3, 4, 5. So the fifth digital output is connected up to this red terminal here for the LED, and the black terminal, or the black terminal right here, is connected up to ground. And this will allow me to flash the fifth digital output line in the code in order to make sure that I know that the code is alive. So it'll flash on and off, and I'll know that my code is effectively healthy. It's like a heartbeat. The next thing I'm going to do is, since I've got the first digital output connected up to the first post on the keypad, and that will give me the first row, I need to have 3 digital inputs connected on the Phidgets board, connected up to posts 5, 6, and 7 of the keypad. So I'm going to take the first digital input, and I'm going to connect it up to post number 5 on the keypad board. Whoops, hold on, let me get that again. It's a bit fragile here. Like this. Here's number 5. There we go. Then I'm going to take the second digital input line, and I'm going to connect it up to post number 6, like that. And I'm going to take the third digital input and connect it up to post number 7, like this. Okay, so now I have LEDs connected up, or an LED connected up there. I've got the digital output line, the first one, connected up to the first pin on the keypad board, and I've got 3 of the digital inputs on the Phidget board connected up to the posts 5, 6, and 7 on there. And this will allow me to detect buttons 1, 2, and 3. So this row right here. In your lab, you'll want to do more than that. But this is at least to give you an idea before all my connections get all spaghetti-like. Okay, so now what we find ourselves doing is going back into MATLAB, and I'm going to run the code that I've written that takes advantage of one of the event handlers for digital input, as well as the timer callback. So the code is called Basic Keypad Lab. I've modified it from the template that you have. I'm going to hit enter here. So it says enter, hit enter to start, and what I'm going to do is press one of the keys 1, 2, or 3 as this is going. Okay, so I'm going to hit enter, and it should say that it's detected keys. So we've started. There we go. Button 1 has been detected. Sometimes I have to press a couple of times. There we go. Button 2. Let's see. There we go. Button 2. And button 3.